to algorithms section. So today we'll discuss what algorithms are. As usual, they are very important topic in computer science, and they have in many problems there are key general problems that ask for output with the specific properties when they are given a valid input. Now, for example, in a geometry class, if you recall that the way to bisect a line was to when you want to bisect a straight line, what you do is primarily you have to put an arc here and another arc here and then another arc here and another arc here, and then you join these 2 points. So how to draw this arc was to first you put your cursor here, compass here, one point of the compass here, and then open it more than half of the line, and then draw this arc here and this arc here, and then you put your compass here, and then you open it so more than half of this the line, and then draw another arc. Wherever they intersect, the four arcs, you join those 2 points. So this is the method of dividing uh, a line into two parts. Now this is so simple and it is so briefly explained because I still remember it from a lot of years ago I studied it. But the important point is that it's something of steps. It is a set of steps which can be easily be repeated, and if I write them down, anybody can read them and do them. Now, in this case, the input was this line. For example, they gave us a line as an input, and the output that was required was to the specific properties of the output was that this line had to be divided into two parts. Now, the first step is to precisely state the problem using the appropriate structures to specify the input. Now, in this case, we were given the task of dividing the line, and we then solve the general problem by specifying the steps of the procedure that take a valid input and produce the desired output. This set of procedures is called a algorithm. Now, algorithm is primarily the set of steps. Now we move to the formal definition of an algorithm. An algorithm is a finite set of precise instructions for performing a computation or for solving a problem. Now, the algorithm was primarily described by an, a scientist. His name was Abu Jafar Muhammad ibn Musa al-Khwarizmi. Now, al-Khwarizmi is a difficult word for me to even pronounce. It's a Arabic word, I think. I'm not sure which language this comes from, but what my hunch is that it's an Arabic word. Maybe it's not an Arabic word, but still it is a difficult word. So when it was translated into different languages, from Arabic to Latin or Latin to Greek, and I don't know, maybe English. At that time, this name was changed, and people started calling it algorithm. So his so the algorithm became the name for the process of. So the algorithm is this finite set of precise instructions for performing a computation or for solving a problem. Now, Al-Khwarizmi is also famous for another achievement. He wrote a book. The name of his book was Al-Jabr wal Muqabla. Now, Al-Jabr means to reduce something, and by Muqabla we mean to compare something. From the word Al-Jabr, the word it became Al-Jabra. So he has this contribution as well. So an algorithm is a finite set of precise instructions for Now let's describe an algorithm for finding the maximum value of a sequence in a finite sequence of integer. Now let's describe an algorithm for finding the maximum value in a finite set of sequence of integers. Now, for example, if you have set of integers, maybe like these, maybe the integers are 10, 12, 10, 15, 8, 6, 4, and 3. 3. Now, if this is the set of integers, now what we do is we start with it and we say, okay, set the temporary maximum. So what we'll do is we'll blindly follow the steps, even if you understand what it does or not. But the idea is to be the algorithm's idea is to write the algorithm in such a way that anybody can follow it blindly. So let's start it. Set the temporary maximum equal to the first integer in the sequence. Now I say, okay, my maximum, my temporary maximum is equal to the first integer in the sequence. So what is the first integer in the sequence? That is 12. So we write 12. Okay. So now we do go to the next step. And now if we have only one integer, if you have only one integer, in that case, the maximum would be 12. Okay. So because the sequence has only one integer, therefore the maximum is 12. So we have already found the maximum if the size is 1. But it says that compare the next integer in the sequence to the temporary maximum. Now here is the little mistake, because if there is no next integer, what to do then? So but still it's okay. If let's say what to do. If it is larger than the temporary maximum, now I have 10 here. Now 10 is not larger than the temporary maximum, which is 12. So I wouldn't do this. So I would not set the temporary maximum equal to this integer because it is not larger than the temporary maximum. And the next step is repeat the previous step if there are more integers. If not, stop. Now, if I don't have any other integer, for example, if I have 15 here, if I didn't have any other integer, my temporary maximum would have been 12 out of 12 and 10. But now, since I have more integers, what would I do? I would go back to this step and repeat it. Compare the next integer to the sequence. Now, the next is 15. Now, if I had to compare it with 12, and since it is larger than 12, so what I'll do is I have to cut it off, and I'll say okay. Now my maximum is not 12, it is equal to 15, right? Now this is how the value is changing, and then I go down and say okay, repeat the previous step if there are more integers. Now since I have more integers, I have to compare 8 with the temporary maximum. It is not greater than 15, so I go to the next integer, which is 4. That is also not greater than temporary maximum. And similarly, I go to the next integer where it is 3. That is also not greater than 15. So therefore, my maximum is 15. So he says when the algorithm terminates, when does it terminate? When there is no more integer. So after 3, I don't have any other integer. So I have to stop. My algorithm is stopped. The temporary maximum is the largest integer in the sequence. So which is true that 15 is the largest integer in the whole sequence of integers. Now, for example, if I say that this algorithm is not correct, let me give you another algorithm. That algorithm is to find, that is one simple thing, which has one simple line, and it says the third integer is the maximum. Now, what happens here is that in this case, this is correct. One, first, second, third, that is integer is the maximum. So you don't have to do any checks, you don't have to do anything. You have to just return me the third integer, and that is the maximum. So this is correct in this case. But if, for example, I have another integer before 12, and I have maybe, for example, if I have a number which is, so if I have before 2 before 12, in that case it is the third integer is 10, and that is not maximum. So this algorithm, the new algorithm that I have written with a single line which says the third integer is the maximum, that has failed. So this algorithm has failed, while this still performs well if we apply this algorithm on this new sequence. So why am I saying this is because we'll have to go and look at the properties of algorithms. Now, what are the properties of algorithm? We have to be very sure about them. For example, the first property of an algorithm is that it has an input. Now, every algorithm has an input. An algorithm has an input from a specified set. Now, that means that if I talk about some input about of an algorithm, I will also have to specify what kind of input does the algorithm expect. Now, the previous algorithm has successfully found the maximum value from a set of integers. Now, but if I give it, for example, a set of real numbers, it might or might not work, right? So that is not something that has been told to us. It has said that if you give me a sequence of integers, I'll be able to find the maximum. And also, it didn't say that if you give me a set of, for example, maybe a set of glasses of different sizes, it will find the maximum. No, it will not find the maximum from a set of glasses because this algorithm is not been designed for that. So the input would come from a very specific input set. So we have to specify what kind of input is given. Similarly, the output. From the input values, the algorithm produces the output values from a specified test. So the output would also come from a specified set. Now, in our case, when we talked about the maximum algorithm, the same sequence gave us the output. For example, the maximum number came from the input. Now, but for example, sometimes the output might not be from the same set. For example, if I have an algorithm, what it does is if a student gets marks between greater than 80, it returns an A grade. And if the marks are between 70 and 79, then it gives a B grade. And then if it is between 60 and 69, it returns a C grade. And from 50-59, it would return a D grade and sorry, D grade and less than 50. If the number is less than 50, then it returns a F. Now here, what is the input of the to the algorithm? The input to the algorithm is the number of marks obtained by the student. And while the output, it is from a set of integers or maybe decimal numbers can also be there. So we might say that later it could come from a set of real numbers. But however, the output it gives us are letter grades. For example, it would give an A grade, it would give a B grade, it would give a C grade, a D, and an F. So the output could be from another set. The output values are the solution of the set. So the output values are told to be said to be the solution that the algorithm was applied to find. Correctness. An algorithm should produce the correct value, correct output values for each set of input values. So whenever we give a, for example, this, if you look at the algorithm I wrote here, now this is not correct. It is correct for only one or maybe lots of examples, but it is not correct for all cases. So this is not a correct algorithm. The one we used here, that was a correct algorithm. It can produce the output for all kinds of inputs for each set of input values. Finiteness. An algorithm should produce the output after a finite number of steps for any input. So this is also a property of an algorithm that it should be able to produce the output after a set number of steps. We should be able to say that, okay, if you give me a sequence, if you perform, let's say, for 1 billion steps, you will get a result. Even performing 1 billion steps would take time or maybe a lot of time, but still we would know how many steps there are there to get the result. But if you say that you keep on performing until you get a result, that means that the algorithm isn't giving us a finite result. finite, this is not finite algorithm. Similarly, we have effectiveness. If it is possible for each step of the algorithm to perform it correctly and in a finite algorithm. So each step should also be we should also be able to perform each step of the algorithm correctly and in a finite amount of time. That would lend effectiveness to the algorithm. And lastly, the generality of the algorithm. It should work for all problems of the desired form. It should not be for specific case. For example, like I just gave the example of the maximum algorithm. That is just for I said, okay, give me the third number, that is the maximum. That is just for those sequences in which the third element is maximum. It is not a general solution. So algorithm should also be general in its it should also be general. Now let's look at how do you write algorithms. Now I don't like this whole slide. I just say that okay, write the algorithm which is understandable. If you want to write an algorithm in English, for example, this was written in English. There is no programming here, so it is fine. So what we can do is we can use something like this. So a pseudocode is a code which cannot be compiled by any compiler, which is not written in any specific programming language. However, it looks like a code. For example, this code, if you write in some language, maybe in Pascal it would compile, and maybe there it would not compile. But in general, this is not code that can compile, but it is very good, very near to a language. So any programmer who just looks at it would know how to implement it. And if a programmer wants to write a new algorithm, if he uses pseudocode, he would be easily able to do it. But there is no restriction. One can write it in any way one likes. So this is how we talk about algorithm. So similarly, there are certain conventions here which are being followed. For example, the semicolon equal to, this is assignment. Now, if you say, okay, semicolon equal to, this is assignment in this case, in the pseudocode. Similarly, when you do equal to, this is C++ equality, equality test, right? So C++, if you want to test equality, you write to equal to, but in our book, in this case, it would be only equality test would be done by, you don't have to be, if you write the equality test can simply be given by one equal to sign. So this is one introduction to algorithms, and it is one algorithm that we are talking about. I hope this clarifies some of the concepts. More would come in the next video. Very much.